All right, guys. So we're just going to do some problems. So there are mainly two ways to do it. You guys, he mentioned dy and dx, right?
Yeah.
Dy and dx. Yeah. So if I have a graph, y equals x squared, and y equals x plus 2. So you graph them. So what's the first thing that you should always do given this? Or you're supposed to draw this one. To find what? Yep. X squared equals to x plus 2. The first thing you should always do is find the intercepts. So let's do that. So what would this factor out to be? Yep. X minus 2, x plus 1. X is equal to 2 and negative 1. That tells us that at 2, 4 and negative 1, 1, they intersect. Okay? Those are the two intersections. That's going to be something like part 1 of the question. And then you have to find the area enclosed. Yeah, this area. They will probably ask you to do both of them, okay? Using both dy and dx, which means doing both vertical and horizontal strips, okay? So, looking at this, what is the optimum way to do it? Just by looking at it. Would you rather use horizontal strips or vertical strips? Vertical. Okay. Because if you were to use horizontal strips, you do horizontal, okay? Until you reach this point, then your functions would change. Your top and bottom function would change. This would be your top function, or yeah, we can say this would be your bottom function, this would be your top function, if they were going like that. Okay? Yeah. This would be the top function. I don't want to say top. Let's just do right and left, okay? This would be the right function. This would be the left function. Until you reach this point, this would be the right function. This would be the left function. So you need two integrals to find the total area. Yeah.
So why exactly do you need the strip? They didn't really explain that.
The strips are, you know how we had the rectangles? These are rectangles. This area difference is dx, which is tangent x. Essentially, we're drawing little strips that go all the way down. That's what integral does, essentially. That's what we learned from the summation. It's when the dx goes to 0. Integral is just a way to do it quicker, and you can go more into it, and he did, but I'm not going to go into that. So, this would be a dy. It'd be a dy. A horizontal is a dy because it's a change in the y axis. Okay. No, this is just one of those quick. Yeah.
Oh my.
Yeah. Yeah. When you do them vertically, that's a dx. That's something you should know too. You don't want to accidentally mix them up. Why is the vertical a dx? because it's drawing a rectangle with the width being in the x-axis. Okay? It's a rectangle with tangent x, like we drew rectangles before with the summation. When we draw a horizontal line, it's a change in the amount of the y-axis, so it's dy. You had Purvis, right? Or no, yeah, so you already learned. So if they ask us to do vertical elements, what do we use, dy or dx? Dx. Since dx is going down, we know we have a top and a bottom. Okay? Those are the two functions that we do. Any questions with that? So then it's not tough once you realize that. And we know vertical is the most optimum way to do it. So the integral is between what domain? -1 and 2. Because that's the x-axis and we're doing dx. Okay? It's like summation basically. With dx. You're going from -1 to 2. Do you guys understand why? I don't know why. Yeah, it's the distance from here to here because that's the area we're calculating. And we're using -1 and 2 because we're using dx. Yeah. Okay? Now, if we were doing dy, what would we be doing? From 0 to 4 essentially all over, but from 1 to 4 and 0 to 1. Okay? So we'll get to that, but the integral is going from -1 to 2, and it's y2 minus y1 dx. So from here, it's plugging in values. Our top function is our y2 function. Our bottom is y1, and it's top minus bottom. So y2. So it's x squared minus x plus 2, or minus 2. Sorry. Yeah, I messed up. You guys are x2 x plus 2 minus x squared. Yeah. Top minus bottom. When you have an integral, okay, just looking at this, so essentially we're taking the integral of 2 minus x plus 2 from -1 to 2, and that includes everything, including the sections that we don't want, right? If we got the graph. Yeah. So x plus 2 is including everything here that we, okay? When we include x squared, we only want this area, right? So when we do the integral of x squared, it tells us what's under it. Okay? Because taking the integral of it is basically drawing little rectangles underneath it. Yeah. So that's what we're doing. We're doing the integral of x plus 2, all of the rectangles under it, minus the rectangles under x squared. So then we're left with the middle area. Okay? That's what they were showing with the whale. Well, that's, essentially that's what the rectangle is. That's okay. So once you realize y2 minus y1, it's just an integral, a definite integral. So what would it be if I do the integral of it? What's the integral of negative x squared? The integral of negative x squared. Yep, negative x squared over 3. Yeah. Just make sure your signs are correct. If you want, I'll do that. So x is x squared over 2 plus 2x minus x cubed over 3. So negative 1 to 2. Equal to 1 half times 2 squared is 4. Negative 1 squared is 1. So 4 minus 1 plus 2 times negative 2 minus negative 1. So we're positive. Okay. Minus 1/3 times 2 to the 8 minus a negative 1 because we're negative 1 cubed. I got pretty low volume there. 4 minus 1 is 3, so that the first part is 3 halves. 2 plus 1 is 3. 3 times 2 is 6. This is 8 plus 1 is 9. 9 divided by so 3 halves minus 3, which is minus 3. I did that wrong. Plus 9. Yeah. Any questions on that? So on the test, they might tell you, do it using the most optimum way, which means you would need to use only one integral, and that would be using dx. Okay? So if you do it with dy, you'd get it wrong. Like, you'd lose all the points. Plus 3 halves, that's this part. 6 minus 3. 6 minus 3. Any questions on that? I'm gonna. Yeah. Oh. Yeah, now we do horizontal. So you can tell with the horizontal that at this point we have an equal. Yeah. We're doing it for the same problem. One thing though that you should always do is convert your functions into with x and y. Okay? So y is equal to x squared. That becomes, you just take the square root of y. So x is equal to the square root of y. Okay? This one, x is equal to y minus. sort of to show it. When you graph it, you should like draw a line saying y1 is equal to x squared, x1 is equal to square root of x. They want to see that. So y2 is equal to x plus 2, x2 is equal to y minus. Those are worth points. And then whenever you should also always show your, so this would be dx, and this would be a dy. So with that, like those are little things that they'll look for points. Okay. So for this one, the area is broken into two parts. When doing right and left, what order do you go? Yeah. Yeah, so you go right minus left. You do top minus bottom because, let me drive forward. Let me see if I can show it like I did with the other guy. Like if you were just looking at this side, all the area of the right would include everything. Okay? If you were to take the integral of this function, square root of y, it would include everything, including the area that you don't want. So then you need to take away by taking the integral of that. By subtracting that makes sense. Or I could just draw. Say we wanted the area of this. Okay? By doing the integral of the rightmost function, we get that as the integral. Okay? By doing the integral of the bottom function, we get what's under it. Okay? So when we do the rightmost minus the left one, we get the middle section. It works out, but then you have to realize that whenever you have, say, we're doing with dx, everything under the x-axis is a negative area. So if you think through it, it'll work out. But I don't want to talk about it right now because otherwise I get confused and it's important. Okay, let's just go through with this. So the first domain is we're going from 0 to 1. So we found out that the function of this side is square root of y. Okay? What would the formula for this little section of the curve be? So this would be negative square root. It depends what you want to do. If you were going from 2 to 1, you'd get a negative area. Or sorry, yeah, because we're going backwards. So we're going from 0 to 1. What is the rightmost function? What is this function? In terms of square root of y. And we're subtracting what? Negative. Sorry, negative square root of 1. From 0 to 1. And we have dy, because we're using vertical, is to change the y with plus the integral from 1 to what? 2. Sorry, no, 1 to 4. Because we're going dy now. And the rightmost is square root of y minus the function y minus 2. Do you guys all understand how we got this? Any questions? Yeah. The domain is from 0 to 4, because that's with the y-axis. Do you have a question? Yeah. So let's call this x3. Okay? So this would be x1 minus x3. Okay? x3 is already negative square root of y. x1, from previous, we need square root of y. Yeah. Okay. All right. So what's the question? The y is not negative. The whole quantity is negative, so it can be negative. It's like, the best thing I can think about is like you have a circle. It can be broken down into 2 equations. The top is a square root, the bottom is a negative square root. Just like that. At 1, we found that as an intersection point. Yeah. We found -1. Yeah. Because that's when the functions cross. We know then doesn't make sense. Yeah. That's from. Why are you there? Oh yeah, because the function goes. The entire area that we want goes from 0 to 4. Well, you have to include everything. From 0 to we're going to 1, because that's the y value we found at that intersection. And then from 1 to 4, because that's the y value we found. You have to look at everything. So, okay. So this becomes the integral from 0 to 1 of 2 square root of y dy. Okay. Plus 1 to 4. 0. That's square root of y minus y plus 2. So any other questions on that? No? Are you guys confused? I'll go over it one more. I'll read all. Also, so here's the graph. Okay. Oh yeah. Well, we stop it here, right? Yeah. Why are you seeing 0 and negative? That's the x value. Okay. We're using the y-axis. In the y-axis, we're looking at from 0 to a positive 1. So from 0 to positive 1, we have the function on the right minus the function on the left. Okay? So the right was square root of x, square root of y. The left was negative square root of y from 0 to 1. And then these two integrals, square root of y, and this is y minus 2. Okay? Are you guys still confused? No? So then you do the integral. What's the integral of square root of y? Yep. Yep. So it's 2 times y to the 3 half divided by 3 half. Again, it just, well, that one we have to multiply by 2. This time, oh, yeah. This goes from 0 to 1. The second part, y to the 3 halves, all over 3 halves, minus y squared over 2, plus 2y from the 1 to 4. Any questions on that? That's just doing an integral. And you do it the same way as if it were x. dy is basically turning the graph so that instead of our x-axis being horizontal, you can think about it as our y-axis being horizontal. Just that much. So did you guys all copy this? And then it's just plug it. The first part, it was, and then once we plug them in, it'd be 4/3 times 1 to the 3 halves minus 0 to the 3 halves. Plus 2/3. Two-thirds times 4 to the 3 halves minus 1 to the 3 halves. Okay. Minus 1 half. 4 squared minus 1. plus 2 times 4 minus 1. That's equal to 4/3 plus. What's 4 to 3 halves? Yeah. It'll just be 8, which means minus 1. So plus 14/3. This is 16 minus 1. So that's minus 15 now. 2 times 3. This gives us 18/3, which is a 6. So we have 12. Or we can say 24/2 minus 15/3, which is 9. And you guys should have done enough problems and everything by now to do this quickly. Yeah. It just depends on what you do. I like to keep everything fractional. Preferably I would have converted this to over 3 and 6/3 and then solved it down. But we didn't need to do that in this case because we had a 6 and a 6. So it depends on how you can do it quickly. Because the last thing you want to do is use up time on little things like simplifying. Okay. Are you guys good with that? We'll get into a bit of it. Well, it's not that bad. Can I erase all of this? So, your practice test may be very similar to what I'm doing. Say we have y is equal to sine of x. And then y is equal to cosine of x. They could do, or they probably will have a problem like this. So, we have pi somewhere, pi/2 somewhere. I'm not sure. Right. So this is y is equal to sine of x. Y is equal to cosine. What? Yeah, you should know how they look. No, they're no. Yeah. So they ask us to find the value of the area shown. So we have to find the area. Okay. So just by looking at it, we know we need 2 integers. Okay. What would be the optimum way to do it? Yeah. Were you saying the answer? Okay, yeah. So if you were looking at it the way to know which way to do it is to find the lowest amount of integrals that you need to do. Okay? That's by looking at the domain. So if we were to use vertical lines through all of stuff, we'd use vertical lines continuously until we reach this point. We wouldn't have any issue. And then we use vertical lines until the very end. Okay? Yeah. If we use horizontal lines, we'd have an issue at this point, because then the curve, the right and the left change. Okay? So we use dx. But there's two parts to it. So this one. Where do you guys think sine and cosine cross each other? Where do sine and cosine equal each other? Pi over 4. Okay? That tells us that this is pi over 4. Okay? And this would be it's 3 pi. Or wait, never mind. Just pi. Oh, sorry. Yeah. This is just pi. So we're going to pi. Okay? Yeah. Were you using a pen or a pencil? Oh, you're fine. So we're going from 0 to pi over 4. So pi over 4 is something that you need to figure out. You can tell that by, if you know your unit circle, at pi over 4, they both equal 1 over root 2. So from 0 to 4, or pi over 4, that's from here to here. Okay? We need to do top minus bottom. What is the top function? Cosine. Bottom function? Sine. So it's y1 minus y2 dx plus the integral from pi over 4 to pi. The top function is now sine y2 minus y1 dy. Sorry, dx. Yeah, dx. What? Let's hope not. I don't know. Up to this part would be fine. This part, I'm not sure. Yeah, you need 4 different integrals. 1, 2, 3, 4. And then you need to know what that. This side would be fine because y is equal to 0. Okay. No, you never. Well, I think you can do it. I wouldn't see any problem with it. Not really. Not really. If you found one section of the graph that's better with dx, one section with dy, it would confuse the graders a lot and everything. But it would get you the right answer if you did it correctly. Yeah. Okay. So from 0 to pi over 4, y1 is cosine, So cosine minus sine of x dx. Pi over square root of pi of sine minus cosine dx. So this shouldn't be that bad. What's the integral of cosine?
No, it's not right.
Regular sine. So sine of x. What's the integral of sine? Negative cosine, but we are subtracting it. So it's plus cosine from 0 to pi over 4. So make sure you don't get mixed up with the plus and minus. Plus, the integral of sine again is negative cosine. Integral of cosine, positive sign, so it's minus sign. And the integral from pi over 4 to pi. Sine of x, what's sine of x is pi over 4? Yeah, or 1 over square root of 2. Okay. What is cosine of pi over 4? 1 over square root of 2. Sine of 0 is 0. So then we have minus 0. Cosine of 0 is 1. Minus 1. Did I do that right? No. We're subtracting 0 minus 1. Okay? Plus cosine of pi. What is cosine of pi? Negative 1, not 1. So then we have a minus cosine of pi. That's positive 1. Sine of pi is 0 minus the quantity of cosine of pi over 4. So it's minus 1 over 4. Minus sine of pi over 4 minus 1 over square root of 2. Actually, let's do sine of x and cosine. Did I? Yeah, I did that right. Here?
Yeah.
Cosine of pi over 4 and sine of pi over 4. Actually, let's put on the other one. It becomes a bit easier. It's what?
Our high school decrease of rational, make rational.
Yeah. Depends on. In high school, they want to. Here it doesn't. Square root of 2 over 2 plus square root of 2 over 2 square root of 2 plus 1 plus 1 minus plus square root of 2. Actually, be a minus one. One of them should be a minus. This. Yeah. Yeah. Cosine of 0 is 1. So minus the quantity when we plug in 0. So this is 2 over 2. For the intersection, I think they actually want to see the work in how you got pi over 4. And it's not, it's not tough. How do you normally find an intersection? Let them equal sine of x is equal to cosine of x. Okay? What do you guys think we should do here? We could divide pi by cosine. Okay? That, therefore, tangent of x is equal to a 1. When does tangent of x equal to a 1? Pi over 4. When x is equal to pi over 4. That's how you would go about finding x is equal to pi over 4.
Well, what do you have to know that the arc is 1?
Yeah. At pi over 4, you should know tangent of x. Tangent of pi over 4 is equal to 1. Like, you should know. There's a lot of little things you need to know that they don't mention. But you learn them by, I guess, coming SI or doing problems. Can I erase this? Any questions with this? Okay. Okay. Say we have the integral, not area, but find dy dx of the integral of sine of x to 0 of 1 over the square root. We can do 1 minus b squared. I think that works the best. dt. Okay. The dy dx is the actual d. Yeah, it should be. No, it should be dx. Okay. Taking the derivative of an integral is essentially mute. Okay. Thanks for coming. Because integral is exactly antiderivative. Okay. But when you have definite integral, you need to plug in those values. That goes to the thing where it was f of b minus f of a. Okay? The first thing you should always do, we can do it like this, but since sine of x is our lower domain, we can just multiply by -1. So then we have d over d of 0 to sine of. Okay? That's something that you guys should have learned. Yeah, just cosine will get learned. Otherwise, we'd have to do like something minus or 0 minus. We already took care of the negative. It's not important, but yeah. So on a test, I'm just saying this would be the optimum way to do it. So we have that. This is equal to what you guys learned is negative f of t times d over dx of sine of t. Sine of f. That's the process that you guys learned. Then you do the derivative of your domain. Okay? I can try to find what it showed me. Yeah, that was it was given, but it's really obvious why, and I'll show you. Yeah. It was called Leibniz rule, where you have the integral or d of d of u of x and d of x of f of t d of t. Okay? This is equal to f plus v times dv dt or dv dx minus f of u du over dx. Okay? Since our lower is u, plus the derivative of constant is u. Okay? That was Leibniz's rule that you guys learned in class, and that's what we're applying to this. So this is equal to minus f of t what? Well, this would be our first part, such as that, and then we'd have minus a minus 0. Yeah, this is just a general formula. In this, our v would be sine and our u would be 0. Look at your objectives. I would not think, they wouldn't. Yeah, the objective is just to evaluate it. So then we have 1 over square root of 1 minus sine squared times the derivative of sine cosine. Okay. What can you do to simplify this? Yeah. 1 minus sine squared. What does that equal? That's cosine squared. Okay. So this is equal to the negative we plugged in sine for it. Yeah, that's part of the rule. Like how we have f of b with v in it. So these are our t domains. But So this turns out to be minus. You have to be careful. That's minus cosine. This is the square root of cosine squared x. Okay? That's actual value. Minus cosine of x over the absolute value of cosine x. Okay? Well, it's the square root of something that's squared. Yeah, that's an absolute value. Because that always needs to remain positive, whatever x value. So then, this doesn't matter. This is essentially equal to -1. But if you had secant or some other things, you would need to care. Do you guys see how this all worked out? Yeah, that would be that. What are you talking about? Yeah. Well, we took the integral from 0 to sine of x. We just didn't show the 0 part. Okay? It's 0. Yeah. Because it's a constant. And then the function with t, and what is our upper t value? Sine of x. So then, sine of x. And this is just some simplification thing. You'll probably see it on the practice exam, but I'll show it to you anyway. Say we have negative secant squared x over the absolute value of secant of x. Okay? We can't just simplify it. This is equal to the negative absolute value of secant of that quantity squared. Because in the end, it always has to be positive, right? So that's why we need absolute values in order to cancel. If this needs to always be positive. Something squared, so secant squared of x always needs to be positive. Okay? If I were to just cross off right now, our answer of this section, we'd lose the absolute value sign. We'd lose the squared. So then someone could make it, ignoring the negative, someone could say, someone could have a secant value which would make it a negative. Okay? Someone could have an x value which would make this secant negative. So in order to protect from that, we make it an absolute value and then square. Does that make sense? So this way, the information is that it always needs to be, ignoring the negative, this always needs to be positive. So when we cancel one of them out, we just have negative absolute value of secant. That will probably be on your practice. Now what we have as the answer is constant. The reason, like, say, I'm going to take out the negative. If we were to just divide the secant out in the bottom, there could be an x value for which secant equals a negative number. Okay? But with this original expression, we will never have a negative answer. That's why we need absolute values on it and then divide it out. Because then in the end we have absolute values left. So we'll never have a negative answer. That was this little thing that I wanted you guys to see. Sometimes you will need to simplify. And then there's other stuff. We could go over. So do you guys understand the idea of displacement and total distance? Displacement is the total distance is all of the distance traveled, say like a particle. While displacement is just how far it went away from the starting location. Say we have a particle, and this is the x-axis. Okay. It went from here to 2, and then at that point, it turned around, and then it went back to place 1. Okay. So this happened when time was equal to 1. This happened when time was equal to 2. Okay. If the problem asks us for the total displacement between from 0 to 2, from 0 to 2, it just be 1. And if this was a function or something and you did the integral, you'd go from 0 to 2 and your answer would be 1. But if it asks us to find total distance, you need to find that there was a 0 here where the particle velocity was 0, so the derivative was 0. It'd be like a root u. Yeah. And you need to then do the essentially the displacement from 0 to 1 plus 1 to 2. I think you guys should already know that. Yeah. Yeah. And they give you the velocity function, so you get VFT, and since they want distance, that's SFT. So you do like integrals. So for the total displacement, your integral would just be from 0 to 2 of VFT. For the total distance traveled, you'd have 0 to 1 of VFT plus from 1 to 2 of VFT. dt. Okay. Did they do a problem like this in class? I don't think so. And you'll have a problem like this on the practice exam. You'll see what it. You'll get experience with it. And I would highly recommend watching. I don't know if they covered the trapezoid rule in class, but I think it's just on video. And the Simpsons rule. You guys should definitely watch those. And take careful notes. But that will be on the exam. Any other questions? That's pretty much it. Yeah, like your homework gets complicated problems, and you see more problems in the practice exam. That's how you learn. Sort of, the SI practice exams are part of the course in a sense, in order to help you get to the place that you need to do well on the actual exams. So if a student were just to go to class and then went to test, they wouldn't do so well. Unless they like did all the homework perfectly and then looked at everything carefully, and, you know, because and then that's how you learn like little tricks and stuff.